All right. Oh, this is.
Yeah, it's not my class.
Yeah, that's something else. I was thinking that was my Cloud9 terminal. Do I not have Cloud9 open? So you just missed that. The thing I had up on the screen was the Klingon alphabet. We were debating in 200 the other day whether we can support larger number conversions than base 37 if we used Klingon. So we spent 20 minutes on that. The answer is no.
I realized this morning they could have been here this afternoon.
Right. So do I not have? Oh, there it is. Well, out of curiosity, how many of you signed up for the hackathon next Saturday?
This Saturday coming up.
This Saturday come out. It's only a 9 a.m. to 5 p.m. It's not like an overnight crazy commitment. And it's in downtown Milwaukee. Also, not a long drive. So if you signed up, message me so I can get you on the list so we can put people in the groups, and also we can make sure we have transportation to get everybody down there, unless you just want to drive yourself. But at least give me the list of people. So you signed up, you said? Doc? Did you message me saying you signed up?
Yeah, you messaged me.
Did I really?
Yes.
So you're on my list.
I should be.
Yeah, see, you're just so forgettable is the problem. No, I started a list. If you message me and I message back, then you're on the list. Okay, so let's see. At the end of last class, we had it working, but it was doing the thing where it was sending the message in multiple parts. Is that correct? All right, so let's find out why that is. Isn't that weird that it actually sends you back to your main? Like it chooses to go ahead and reopen your terminals, but just sends you back to your home directory rather than hold on a second. Delete chat. Okay, so we need to get that. Hello from a child. Do you have candy? Okay, well, we received, let's see. So on this is reply received. Who's printing out reply received? Is that the, okay, that's this guy. So we're receiving a maximum of, okay, we should be able to receive the whole message in one read there. So let's look at the chat server side of things. Because right now we are creating a string. Where's the string we're sending? Oh, here we go. We're just arbitrarily putting a 2000 in there. So let's do, if we send a smaller message, let's just do hello from, like that. That will be 1, 2, 3, 4, 5, 6, 7, 8. That'll be a byte. And then OM, so I wonder if we're going to get hello from, and then OM as a second message. Let's see if that's the case. Good old-fashioned child stuff here, Abe. Oh, I thought you were, when I was taking the boat out to the river, I thought you were behind me in your truck. Somebody was driving like a maniac, and I thought you were like screwing with me. And he looked like you, but he looked a little bit like less redneckish. It's like, oh, I get it.
Yeah, I did that once. You were a couple weeks ago. You were pulling out of
here, and then
Oh yeah, I was sleeping.
you weren't paying attention.
Yeah, I was napping.
Yeah.
Well, that's interesting. So we didn't receive. We didn't change the client code at all. Message sent. So it was still blocking, waiting for more. Oh. Let's try this. POSIX Plush Socket. All right, so we could use TCP No Delay on our socket options on the server. TCP No Delay. The current code we have in there is socket server user address. Because to me right now, if the server is running, we are definitely sending a message. We're passing in chat server. Hello from right after it says child stuff, and it was saying child stuff. Yep. So we say sending a message, message sent. So that should have sent over the server, over the socket rather, right here. Let's take the 2000 off and say size of message. Just give that a shot. And let's just recompile the client just in case, but should have no impact. Okay, yeah, so hello FR. Go back here. Where do I stop it? Yeah, so that is 1 byte it's sending. Which means that this guy right here, size of message, must be coming out to 1 byte. What if I force it to be a 9? Will we get the O? Oh, look at that. That's interesting. Huh? Say this again? Well, the client, I think the size of server reply is 2,000. Well, no. I mean, we did get the O here. Where's the?
But it's in the front.
Yeah. But I mean, it's sent 9.
No, it's still the same length. It forgot the H.
Oh. Oh, that's even weirder then.
It's because they got the 9, so it just put it back in the place of
I see.
the beginning.
So you're saying if I take this out and I change it to a 9. This.
If you do Control C and server, it turns off client too. If you stop the server, it
Right.
stops the client.
Yeah, there's the hello fro. So
There's the O.
we shouldn't have, because this is the maximum size that we're allowed to receive.
But is the size of the char pointer?
Let's try setting that to 2,000 and
Is
see.
the size of char pointer a byte?
Should be. That's why it's a byte.
Yeah.
Which is fine. We're just trying to see what that's fixable,
Yeah.
because then we can say, give me the size of star message. We're just trying to prove what the actual. All right, so we didn't change anything there. This should now still give us that same output. Okay, so now we should be able to go back to our server here, and we should be able to send. I'll just do print. Size of message is %d \n, comma. So star message is the actual string. If we do size of that, that should give us in our current setup. Let's make it hello from the child. Do you have candy? It's an important part of this application. Okay, so before the parent sends it, it's going to print out the size of the message it thinks it's sending, which we hope is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. 41 bytes. All right, so we'll save that. Oh, we're actually sending string length of message. We changed that last time. Okay. we print both of those and see if we so let's see what the difference between size of message in bytes and string length of message should be. The number of characters, since each character is a byte for ASCII, those two should be the same. Let's confirm that's the case. All right. Oh. Here, we'll try the string length of message. Printf. Okay. No, these are just warnings. Printf, size of message. 50 expects argument of type 1, but argument 2 has type long. Okay. Let's see if we can do a %i here. Otherwise, we'll do %l because I really don't want to put what the right actual correct thing to put in there. Not with this group, at least.
What is that?
Let's try as no. We'll just do it this way. We'll cast this to an int. Now it should build. All right, listening. All right, so there's the whole message. And over here on the server side, it's 41 for string length. So 41 for string length, and over here on chat client, we received a total of 2,000. So that size of is not giving us the right value. I wonder why that is. So we can say int max size is equal to 2,000. Use max size here. Use max size here. Okay, so that should be able to receive up to 2,000 bytes. We allocate this much memory. Size of. I mean, this will work to extract this value out of it, but this wouldn't necessarily work if size of char was more than 1. Because size of int is something else. So this is string length of message. This is 1 byte for server. That's the size of. Maybe we can just do that for shared memory. It's not in the standard library. Yeah, they're just recalculating it. Okay. So we have to keep track of the size of our memory locations as well. That's fine. Okay. So now this is working. On the client side, we are keeping track of a variable max size that we use to create our actually, just real quick, if I print size of int, that should give me 4. I just want to make sure that's the case. It's going to yell, it wants this as an int. That's on the client, server's still listening. Yeah, size of int is 4. Okay, so size of a primitive type is working, but size of a memory location doesn't give us what we expect. That's fine. So if we know that, we can plan on it. So the actual size of this guy is 2000, but it's technically 2000 times size of char. So we would do this. So we officially have our maximum size, and then we'll allocate max size over here, even though since size of char is 1, nothing actually changed there. We'll receive up to max size number of bytes rather than up to size 1, which was what we were getting before, and that's why it was in byte-sized chunks. Okay, so we already killed that. Let's kill the server. All right. So now our server takes a incoming connection. We call this function child stuff whenever the server sends in a message. So server's listening, it gets an incoming connection. We say client is connected. We add it to our list of connected clients. We spawn off a child. If we are the child, we go ahead and break. What do we do when we break? We say if current PID is equal to 0, do child stuff, and this is where we're going to have ongoing communication with our child. So now we're proving we can send it one way. On the client side now, when we connect, we're connected. Here's our ability to receive stuff from the server. So this is our back and forth. We receive a message. We're just printing it to the screen. We're then replying back with a message, yo, yo, and the server is not currently receiving that message. So we can go back to our chat server. After we send a message, we want to be able to receive a message. So we need to write that. All right, so I'm going to actually steal. Well, I'm going to steal basically those lines, and we're going to put it into a function on the server. So void receive message for right now. We can make I before E except after C, right? Receive message int client FD. We'll steal these couple of lines. We don't need the while loop though. All right, and we're going to receive from client FD a maximum of max size. Okay, and then we're going to go ahead and we'll do a print, we'll do a put S server reply. All right, so that's receive message. So after the child sends a message, we'll then say receive message, passing it the client FD. Like that. And this guy should ultimately receive a message and spit it out. This is a proof of concept. We have to prototype this guy up top. So we'll go ahead and do that. Now we're starting to get to the point where it might make sense for us to make our own header file, but we won't yet, since we're pretty haphazardly just creating new functions. Declared first use of, oh, we don't have an integer error. That's the issue. We're not using it, but that'll make it happy. All right, so now we're listening. Client's going to connect. Client's going to receive a message. And then we're going to send the message yo-yo back. The server should receive that, spit it out to the screen. And there's our yo-yo with a tab in the middle. All right, so we've established it can send back and forth now. Now, when a client receives a message, we want to be able to turn around and broadcast that message to all the other connected clients. The issue is that in our current model, if we bring up our picture here, we have, let's see, let's just call this, say we have 3 connected clients. Each one of those is the child. Then we have the original parent. And we'll make the parent a different color here. And each of these children is maintaining a socket connection to a client. Okay. Now, when a new incoming connection comes in, the parent is currently maintaining an array called clients for a number of connected clients. So the parent knows about clients, and it knows about number of connected clients. There's the 2 pieces of information that the parent is the holder of. Now, when the parent creates a child process, these children get a copy of the current state of things, right? But if this is the first child that was ever created, he's going to have a copy of this array, which has the, the 0, well, has basically himself in there for people he can broadcast to. When the second client gets connected, he's going to get a version of number of connected clients that has 2 elements in it. When the third guy gets connected, he's going to get a version of connected clients that has 3 elements in it. So if this guy sends a message, he's going to broadcast to himself. If this guy receives a message, he's going to broadcast to just these 2. And if this guy gets a message, he just happens to have the full list of currently connected clients. All right, so us relying on the fork command to give us access to that clients array isn't going to cut it in this case, because we want this guy, our original client, to be aware, be capable at the very least, of broadcasting to these other dudes. Make sense? So this is where interprocess communication comes in. So how do we choose how we want to share this information between our children? These guys need to all be aware of the current connected clients. How do we share that information? What are our options? And why did you pick the option you picked?
Well, do they need to be aware of changes in the number of connected clients, like real time?
Well, seems like it. I mean, if I'm this dude and I connected a half hour ago and I'm sitting in the chat room by myself and these other two guys popped in, when I send a message, I'd like to know that these guys are receiving it. Okay, so what are my other options other than shared memory, based on what we know in here? What other things could I use to get that information across? Let's go all the way back to the beginning. What's the easiest, well, quote, easiest way of sharing information between children? Could we use file I/O here? Why would file I/O not necessarily be a bad idea here? I'm not saying it's the correct answer. I think shared memory at the end of the day is going to be the right.
Wouldn't you just want to put like your client ID in there so that it would send all those?
Well, what's the nature of the information? What I need, if I'm this guy right here and I want to broadcast to all the other children other than myself, I think your homework assignment was you can omit yourself, right? And I want to broadcast to everybody else. What's the nature of how I know about this guy and this guy? What kind of value links me to this guy? And what kind of value is that? A file descriptor, is that a cat, dog, char, int? Int. That's an int. Plain Jane int. Is there anything that keeps us from just storing ints inside of a file? I mean, it's not like weird data. If we had like memory pointers and stuff like that, storing that inside of a file is going to be problematic, right? But if we had a file that just had a list of information, it's not really a problem having this all in a file. Go ahead.
Would it be easy to delete that person from the file though?
Easy enough. Read through the file and recreate it. What's the weakness, though, of using a file? Okay.
File gets too large, it's going to take, there's going to be lag.
That's a lot of connected clients. I don't know if that's a valid concern. What about race conditions? If I'm this guy and I'm broadcasting to, quote, everybody, file I/O is expensive, right? So if during that period of time, 3 additional clients connected, they're not going to receive my message. Now, in a chat room scenario, that might not be the end of the world. We're not dealing with, like landing on an asteroid or something. So he missed the message just because he logged in, some millisecond after the, yeah. So, but the punchline is that still gives us an example of a race condition where somebody is added to the file while we're reading from the file. And you mentioned deleting somebody. So right now we're not even handling deleting somebody. Okay, so if we use shared memory, then the nature of this array effectively becomes it's a normal array, and everybody's sharing that single array, right? Okay, so for shared memory, we use shared memory get, SHM get. Does shared memory guarantee no race conditions?
Be a lot harder for someone to.
Strictly from a timing perspective, it might decrease it. If we look at our server code right here and we think about our race condition, what variable on this screen right now is the actual variable that if we were to protect something against a race condition, it would be this guy? What's our problem variable on here? We have 2 choices, right? We'll highlight them. Those are our 2 choices. Which one's the problem? You got a 50-50 shot, and you get a 0 in the course if you get it wrong. So be prepared to defend your answer, Chastity. So you and I, we gotta get our hair. I mean, we gotta get this hair taken care of. I mean, this isn't good what you got there. I was told this morning by Gretchen that I either need to cut my hair off again or brush my hair, and I don't own a comb because my CPAP machine like folds my hair up and stuff. This is as long as I let it get. This is done.
Well, a comb doesn't do the same thing as a brush.
What's the difference? Don't they use brushes on horses?
Don't you take horse tranquilizer or something?
No, it's zebra testosterone. It's totally different. It's a totally different product. All right, out of these two, which is our problem variable? Nobody wants to commit to the. If you get it right, you don't have to take the final.
If I was a kid,
I reserve the right to back out of either of those arrangements. You gotta.
It'd have to be number of connected clients.
Okay.
Because that's what says how many clients are in the array.
Okay.
That's what they're changing.
So.
And that's the one that's changing.
Okay. So well, they're both changing.
Yeah.
But if we're going to broadcast to everybody, we need to know how many is everybody. And we want to make sure that if number of connected clients goes up, that we're broadcasting to all those people. So that means if number of connected clients is being modified, when does number of connected clients? Well, first of all, his answer is correct. But he's not, he still has to take the final. Like, I didn't make the rules and you're from Indiana. So it's...
What's wrong with Indiana?
What's right with Indiana?
I mean,
Although, actually, funny thing with the state of Illinois guidance counselors are telling the students in high schools that to apply to college in Indiana instead of Illinois schools. Because the Illinois government's just completely broken.
yeah.
They haven't passed a budget in a year. It's terrible.
And Indiana has good schools.
Well, I mean, most states have good schools, right? But the problem is in Illinois right now, you're not sure your school will be open in 4 years. I mean, schools, like 130-year-old schools, are closing their doors. Because the state's not giving them any money to run the university because they can't pass a budget. It's like, seems criminal.
So if like Illinois can't pass a budget, does that mean like other states can just take it over?
Like, take over Illinois?
Yeah, like it just
Like it'll
becomes
become
part of
Wisconsin,
it.
Indiana,
Yeah, it
South-
just starts splitting it up into other states'
Southern Wisconsin?
budgets. Yeah.
I have to think that, even though it doesn't seem like it, doesn't Wisconsin feel more like Canada than it should? Like, it seems like a pacifist state, doesn't it? Even though there's a lot of hunting and stuff here, Wisconsin feels pacifist. Where Texas does not. You know what I mean? Like, I could see Texas taking over another state. Like, even just for fun. What's this? They want to?
Yeah. I've got friends from Texas, and they're just like, either we want to be our own, or we're going to take over some.
Well, they're big enough to just be their own country.
Texas has always been kind of
Well, they tried to be their own country for a while.
pretending that it's not entirely part of the U.S.
I mean, I don't think you mess with folks from Texas. I mean, there's a level of instability going on there. I could actually see Texas coming up and taking over Illinois. You have this whole gap of states in between. It's like, where do you live? I live in northern Texas. Like, where's that? Oh, just south of Chicago.
They just leave Chicago.
I'm in a southern Chicago suburb in northern Texas.
They just don't go to Chicago.
They just they build a wall around Chicago.
I mean, isn't it? I think when I was researching this the other day, because my wife's an employee for the state of Illinois, and it's like crazy what's going on. But when I was researching this the other day, 3 of the last 6 governors are in prison for the state of Illinois.
This doesn't surprise me.
Well, Blagojevich was the last one. He tried to sell Obama's Senate seat, and I think he was actually the one that was the least criminal. I think the other guys did way worse. I think they were murders and stuff. I'm not positive, but yeah. So, anyways, yeah. So Indiana can't be so bad if the Illinois is sending you guys our riffraff, or their riffraff. I say our. I grew up in Illinois, but no more. What was the question I asked? Oh, number of connected clients. So this guy, we need to protect this guy when he's possibly changing so that anybody who's about to broadcast doesn't access the wrong value of number of connected clients. Now, so let me ask the follow-up. When does connected clients change?
Right where the, I'll call it a pointer rather than array, whenever it accesses.
So line 39?
Yeah.
Wouldn't that have been easier? Say line 39?
I was gonna explain what it actually does rather than just saying the line.
All right, go ahead.
So that, I'm gonna call it an
You're explaining to me. I thought you were going to explain it to Chastity.
I'm listening.
All right, so what's the issue?
So that's grabbing the field descriptor from that pointer, and then since we have the plus plus after the number of, so it's going to access it, and then it's going to increase it immediately once it accesses it.
Okay, so surrounding this one line of code, this is the critical section, if you will, for when a number of connected clients changes. So it would behoove us if we wanted to make minimize race conditions, specifically around this variable. It would behoove us to protect this with some sort of interprocess communication protection. What could we use here that we've learned about? I don't think we've actually used it yet, but we've talked about it. A semaphore. We haven't used a semaphore yet, right?
No.
Okay. All right, so we have a dude, semaphore, special integer type that controls access to a, quote, critical section. All right, so we come in here, POSIX, semaphore. Sempost, sem get, and sem init. So let's actually do it through the command line here. Oh, I just learned how to make a, nope, not that one. I did. Thought I learned how to make the square root symbol through keyboards. Let's see. Seminit, right? And seminit. All right. So this initializes an unnamed semaphore, and similar to named and unnamed pipes. We're not sharing this guy. It's just protecting the only person who owns this semaphore is the server, the original server. Children don't need access to it, so we don't need to name it to have shared access across the. All right, so we're going to give it a sem type, which should just be an integer type. Let's run this again. Sem underscore t pointer. So this initializes the unnamed semaphore at the address pointed to by sem. It's going to be an integer. The value argument specifies the initial value for the semaphore. So that's the third thing. If p shared has the value 0, then the semaphore is shared between the threads of a process and should be located at some address that is visible to all threads. We don't need to worry about that. Global variable and variable allocated dynamically on the heap. If p shared is non-zero, then the semaphore is shared between processes and should be located in a region of shared memory. Okay, so we can set it to just 0. We're not spawning off threads, so we don't need to worry about it. So to create this, we're going to have an initial sem type, which has to be a integer type. They tell us in here. So let's go this route. got to be in types.h, which we already have in here, right? Yeah, we have types.h in here. So we're going to do sem underscore t. We'll call this block. And let's go, we'll set up our, so we'll say sem underscore init address of sem, or under address of block, then a 0, and we'll give it an initial value of 1. So initial value of 1, semaphores are specialty integers. Then the initial value is the total number of things that can access that semaphore at once. Make sense? Or that can grab a resource at once. And we want to only allow one thing to ever be able to access our number of connected clients at a time. Now keep in mind that number of connected clients needs to be shared as well, right? So most of you have already done this with shared memory. So you already have a shared memory version of number of connected clients, and you have a shared memory version of your actual clients, correct? The array of clients. But right now, you are not probably checking to see if you have access to number of connected clients. So these two guys need to be shared, so that's why they're up here before we spawn off the child. Our semaphore would be here, but this guy gets initialized to 1, and we just read the documentation. If we put a 0 here, this guy is automatically then shared between processes, not threads, but processes, which is what we want. Okay, so this is the old school version of this semaphore. So let me just go back to the documentation real quick, just so I can show you what you'll need to look at. So let's see, I think this is sem inc, right? Sem post, sem wait. So sem post is the guy that increments. Sem wait is you trying to access something, which will then do a post. So if you look at man sem underscore wait, this tells you how to use that guy. So for your homework for Wednesday, incorporate semaphores to protect that one variable so that nobody can read from the number of connected clients variable until it's been released by the server. So the server gets to increment or decrement it if we let people leave the system. But right now, it's always just going to increment. We're not letting them quit. But protect that to guarantee that you don't have race conditions. Make sense? All right, I will see everybody on Wednesday.